Okay, so I'm going to go over the second part of the notes. And okay, so you can find the notes by looking at our website, which is right here. So you would go to Earth Science and then down to Topic 7 or Unit 7, Dynamic Earth. And we are on these first sets of notes right here for Dynamic Earth. Okay, so we left off and you guys had a quick quiz yourself about original horizontality, principle of superposition. Fix that. And now we're going to pick up with evidence of crustal change. Okay, so when we have no crustal change at all, that would be like where we have original horizontality. So in this case, you can see here are the nice lines where sediments got deposited in nice flat layers. They were later compacted, compressed, cemented together to make that sedimentary rock, and we can still see those nice horizontal strata. So in this case, this would be your oldest rock layers, and up here would be the youngest rock layers following the principle of superposition. So again, no crustal change in this picture. Now, as we get into evidence of minor crustal change, in this case, we can see that these sediments have been tilted. And we can see that the left-hand side has sunk down. That's called subsidence, or to sink. And the right-hand side has been uplifted. So this is tilted strata. And you can see that this would probably be the youngest strata. And this would be the oldest strata. Again, if it had kind of, if we were to take it and untilt it and make it horizontal again. This is another example of evidence of minor crustal change. You can see the young Mr. Reba sitting here looking at the rock strata. And in this case, we notice that the rock strata has been folded. You know, how does it get that way? In order to make it fold, that's like taking a piece of paper and squeezing both ends. You're going to crumple it up. So this would be an example of convergent forces. Now, the top of this fold is known as an anticline, and the bottom part is known as the syncline. You don't really need to know that, but it might be useful. So again, if it's folded like that, that's an example of convergent forces, and if you keep pressing and applying that heat and pressure to those rocks, then eventually they're going to switch from sedimentary to metamorphic. Another example of minor crustal change would be faulted strata. So we had our horizontal strata that you can see right here, and we have a big giant fault running through it. Just for size and scale, you can see here's a couple little people climbing up that rock. When we look at this, we know that the rock has been displaced, and by correlating, that means matching up both sides of the layers of rock on both sides of this fault. We can kind of match them up. So we can see that this big slab of sandstone and this big slab of sandstone, if we look at the sequences of rocks above and below, like this little indent and that indent, we can see that this and this used to be at the same layer. And so the right-hand side of this rock strata on the right-hand side of the fault was displaced down, and the left-hand side was displaced up by this fault. Another kind of cool example would be displaced fossils. You know, sometimes we find marine fossils. That means fossils of organisms that used to live in the ocean. We can find them thousands of feet up on mountains, and that's due to uplift of those mountains. And on that same hand, we can find shallow marine fossils in the way, way deep ocean, and that's due to subsidence or sinking. So a really sort of famous example that we have of this are ammonites, which is an organism that used to be found in New York State when New York State was a warm, shallow ocean, can be found in the Indian Ocean, or used to be found in the Indian Ocean. But we can see this marine fossil way up in the high, high elevations of the Himalayan mountains. And that's because the rock that makes up the Himalayan mountains used to be part of the seafloor. And as India slammed into Asia, that seafloor got crumpled up between those two continents, making those Himalayan mountains. Now, some of you guys know that round sort of snail-like fossil that I have behind my desk. That's an example of an ammonite tail. Another example of crustal change are benchmarks. Now, benchmarks are the round discs that we find at the top of mountains or higher elevations. This is one from, if you can barely read it there, Mount Marcy, the highest elevation, highest mountain in New York State. Benchmarks are permanent metal markers labeled with an exact elevation, and over time, these show change in elevation. So as satellites go over the mountains and they beam down signals to measure the height of the mountain, we see that the mountains are changing over time. In fact, the Adirondack Mountains are being weathered and eroded, getting lower, but at the same time, they're also rebounding like a basketball. They're bouncing back up. Now that the ice is gone from the last ice age, the mountains are sort of coming back up, just like if you press on your stomach and then let go, your stomach comes back up. The mountains are doing the same thing. Now, the next two, I'm just going to throw these out here, is the word called geosyncline, and this is really kind of ties in with that idea of subsidence that we were talking about before. When mountains erode, the sediments move to these geosynclines, and the weight of those sediments are heavy on the ground, so it makes the ground sink due to that additional weight. So even though you're adding sediments and rock layers to the bottom, the water depth stays about the same because the crust is kind of sinking down a little bit due to that additional weight. So we can see an example of that here and here. You can see how the ground is kind of sunk down there with the additional weight of those sediments. Now, why do we care? Well, this is a question that was on the June Regents from 2019, and it really threw a lot of people here. It says the cross-section below represents rock units within Earth's crust. The geologic ages of two of the layers are shown. Which sequence of geologic events occurred after the formation of the Cambrian limestone and before the formation of the Silurian limestone? So what we can see here is using page 7 in the reference table, we can see that the rock types are shown there with the keys. So these brick-looking ones are limestone. So it's saying what happened after this was formed and then before this. So we can see that when this formed, it would have been in a flat horizontal layer. So probably uplift occurred first, right? Something had to occur, some sort of maybe convergent force that made it bend. Just knowing that this was bent through uplift gets us to a 50-50. So we know it's got to be choices 1 or 2. Then what happens next? Weathering or subsidence? Well, I'm going to go with weathering and erosion because the top of this bend, those tops of the bend are no longer visible anymore. So just by using that strategy, we can see that the correct answer should be number 1. And then it makes sense that we would have weathering, uplift, subsidence, and then, weathering, weathering, erosion, one more time, uplift, weathering, erosion, and then finally subsidence. And that's it for right now. Stay healthy.